Large language models, or LLMs, are at the heart of today's AI revolution. They're trained on massive datasets, essentially consuming the internet to learn how to respond to a wide range of queries. But even with all that training, their performance in real-world applications often depends on the quality and quantity of data you provide at inference time. In this video, we'll explore why enriching the context you feed into LLMs is so crucial and how it can dramatically enhance their capabilities. We'll also look at practical strategies for finding and leveraging additional metadata to empower your LLMs. LLMs are incredibly data hungry. While their pre-training involves trillions of text tokens, their effectiveness during actual use, what we call inference, depends on the relevance and completeness of the data you provide. If you limit the context, you're also limiting the model's ability to generate accurate and helpful responses. For example, in a question answering system, simply providing the text of a document may not be enough. Omitting details like file names or metadata can lead to incomplete or even incorrect answers, especially if the user references information not present in the main text. The main goal of enriching LLM context is to provide all relevant data that can help the model perform better. This means not just feeding the LLM the main content, but also any supporting information that could be referenced or required for a more accurate response. After watching this video, you'll understand the importance of context enrichment and how to implement it in your own LLM applications for improved performance and reliability. Adding more data to LLMs isn't just about quantity, it's about relevance. LLMs need all necessary information to answer user requests accurately. If you forget to include key details, like file names in a document chat system, the LLM may fail to answer questions that reference those details. This is especially important in applications like classification, information extraction, and keyword search, where missing metadata can lead to poor results. By ensuring all relevant data is included, you maximize the LLM's ability to deliver precise and useful answers. Metadata comes in many forms, and often you already have it available in your application. For text-based systems, useful metadata includes file extensions, folder paths, timestamps, and page numbers. For example, if a user asks for information on page 5 of a document, the LLM needs page number metadata to answer correctly. Similarly, knowing the file type or folder location can help the LLM filter and retrieve the right information. These small details can make a big difference in the quality of responses. Metadata isn't just for text-based AI. In visual AI, metadata like location data, file names, and author information can be crucial. For audio AI, knowing who is speaking, when they're speaking, and where the audio was recorded can add valuable context. By looking for and leveraging this kind of metadata, you can significantly improve the performance of your AI systems, regardless of the data type you're working with. Often, the metadata you need is already available within your application or can be easily fetched. For text-based AI, this might include file extensions, folder paths, timestamps, and page numbers. For other domains, look for similar contextual clues. The key is to identify what information could be useful for your LLM and ensure it's included in the context. This proactive approach can prevent many common issues and improve the overall user experience. Sometimes, the metadata you have isn't enough. In these cases, you'll need to retrieve additional data to help your LLM answer questions more effectively. This can be done by extracting information from documents before they're used in production. For example, you might extract the document type, dates, names, or locations. By doing this ahead of time, you can store the metadata in a database and quickly retrieve it when needed, improving both speed and accuracy. There are two main strategies for retrieving metadata: batch processing and on-demand retrieval. Batch processing involves extracting all relevant metadata ahead of time and storing it for later use. This is efficient and cost-effective, especially for large datasets. However, it requires you to know in advance what information you'll need. On-demand retrieval, on the other hand, allows you to fetch specific data points as needed, providing flexibility when requirements are unpredictable. Both methods have their place, and choosing the right one depends on your application's needs. Retrieving metadata can be automated using LLMs themselves. For example, you can set up a function that takes a data point and a text, then uses an LLM prompt to extract the required information. This approach is used in advanced AI systems, where an orchestrator agent can spawn sub-agents to fetch additional data as needed. While this method is powerful, it's important to monitor token usage as each prompt consumes resources. Properly managing this process ensures efficiency and cost-effectiveness. One powerful use case for metadata is filtering search results. By providing metadata like file type, file size, and file name, you can filter out irrelevant documents before feeding them into your LLM. This is especially useful in retrieval augmented generation, RAG, systems, where you want to ensure only the most relevant data is used to answer user queries. For example, if a user asks about Excel documents, you can filter out all non-Excel files, making your LLM's responses more accurate and efficient. Another important use case is enabling your AI agent to search the internet for up-to-date information. Since LLMs are trained on data up to a certain cutoff, they may not know about recent events. By allowing your agent to perform live internet searches and extract relevant data on demand, you can answer questions about recent news or developments. This approach combines the strengths of LLMs with real-time information retrieval, ensuring your system stays current and relevant. While enriching LLM context with metadata offers many benefits, it also comes with challenges. Deciding which metadata to include can be difficult, especially when requirements change over time. There's also the risk of increasing token usage, which can impact costs and performance. Balancing the need for comprehensive context with efficiency is key. By carefully planning your metadata strategy and monitoring usage, you can maximize the benefits while minimizing drawbacks. To get the most out of your LLMs, follow best practices for context enrichment. Start by identifying all potential sources of metadata in your application. Automate the extraction and inclusion of this data wherever possible. Regularly review and update your metadata strategy to adapt to changing needs. And always monitor the impact on performance and cost, making adjustments as necessary. With these practices, you'll ensure your LLMs deliver the best possible results. In summary, enriching the context you provide to LLMs with relevant metadata can significantly enhance their capabilities. Whether it's through batch processing, on-demand retrieval, or leveraging metadata in search and internet queries, the right context makes all the difference. By understanding and applying these strategies, you'll empower your LLMs to deliver more accurate, relevant, and reliable responses, no matter the application.